We are starting with the same within next 5 minutes.
Good evening, everyone. Hello. Can I start? सबके इतने शॉक चेहरे हैं, पता नहीं कहाँ से आ गए ये लोग. Hello, hello. Hi, guys. Hi, how are you? What's up? They are the only one giving attention here. Thanks, guys. So today we're gonna do something on the data. So we have talked a lot about microservices. We have talked about platforms. We have talked about observability. Now it's the time to see how data acts into the background. So once we have collected the data, we have saved in our source of truth. But once it's moved from the source of truth to our data warehouses, what all happens? and how AK and the team are making that data flow and moving into the Mendelian architecture is something you're going to learn today. So today is for the data evening. Huh? Over to you.
Hello, everyone. Good evening. Thank you, Deepak, for that introduction. So when we talk about data, usually for the tech teams, it's easy to understand that data is, okay, sorry. Okay, so usually for us gathered over here, it is very easy to understand that data is basically a backbone for our business operation. So when everything is dependent on the data, it is very important to structure the data and maintain it somewhere. That's why we always talk about data warehousing. So taking a very niche business use case, let's say someone from the tech team have developed a inspection ready data platform that is solving the business for all the inspection that is happening about the cars in our business. Now, let's say GS listings or refurb team or some other team wants to use that data for their business insights. So in order to make that available, we need a central repository where all the data can be collected together, stitched together, and maintained together. But once we start maintaining the data into the single ecosystem, it is very important to understand the complexity that comes with it. The very first thing that I can list is every person who is using the data can start building their own data silos for their specific business requirements. That will create heavy redundancy in the data. So today we'll walk through what we have identified over the couple of years, what we have improved, what are our plans to improve this, make it a scalable architecture which is future ready as well. With that, let's deep dive into our slides. So in the very first slide, what you can see is a very basic architecture of how data is flowing. Imagine we have source systems which are on the leftmost side, which can be classified in production databases. There are third-party data that are coming directly into our ecosystem, either through GCS buckets, S3 buckets, or API integrations. On top of it, we have our own ML teams who are basically utilizing their ML services to build their data models with the help of their ML algorithms. So all these data are primarily pushed into the data warehouse through different data pipelines. And we'll be walking through all the data pipelines that we currently support and what we are planning to support in coming future as well. Now, when we talk about the data pipelines, there could be very proprietary tools like Fivetran, which you have already heard of, right? And there could be custom pipelines as well, which is helping us to bring all these data into our data warehouse. Now, when we talk about warehouse, it can be, again, a managed proprietary warehouse like Snowflake, BigQuery, Redshift. And we have also enabled one of the functionality with an open source data warehouse as well, which we'll be diving deep into in our coming slides. Now, once the data is ready for us in our data warehouse, what are the next steps? In order to make it available for the business operations team, it is very important to make this data available either on the service, on the application, or on any of their visualization metrics, right? To give them high visibility into their core metrics. So visualization, we can always think about Apache Superset, Tableau, that you guys have already heard of that we are using in Cast24. And Google Sheets is one of the, again, heavily used byproduct, which is basically used by the ground teams and many businesses. And the storage that we are talking about here and in the rightmost end is primarily for sharing the data outside Cast24, maybe with the vendors or partners. So all those capabilities are entertained within the data warehouse architecture. Coming to the next slide, now specific to the tools and technology that are playing a role in our ecosystem, which is basically under the hood architecture of our current data warehouse. So on the left side, you will see all the sources that we have integrated over the period of time, which are flowing into our data warehouse. Starting from the top, there are data coming from CloudTap, directly from BigQuery, because BigQuery give native integration to Spanner database and some other native Google services. All the data are dumped into either GCS bucket or BigQuery in the first layer. So we are extending that data as well into our Snowflake data warehouse. On top of it, Arango is another source that you guys are aware of. For that, NiFi is being used to push that Arango data into S3 buckets, and then buckets are basically used for ingesting those data into our Snowflake data warehouse. Then coming down into the production databases, in the production databases side, we have PostgreSQL managed in both Google Cloud Platform and AWS RDS. There are MySQL in both RDS and Google Cloud. There are Cloud SQLs, MongoDBs, and SQL servers as well. All of these are primarily being pushed via Fivetran. Fivetran also gives us the capability of ingesting application layer data as well, like Google Analytics, Google Drive, Google Ads, Branch, Salesforce, HubSpot, Aircall, Google Marketplace, Webhook, Zendesk, Typeform. All these sources application data are also being fetched and ingested into Snowflake data warehouse via Fivetran. There are some custom pipelines as well, what we have talked about, which are not proprietary, but are managed purely by the data engineering team. So for that custom pipelines, we have several API capabilities built in Python, which are pulling the data from APIs of MessageBird, FTPs. There are ML services that are writing the data from HDB or Google BigQuery into our Snowflake using custom pipelines. Now, when we talk about the data warehouse, what you can see over here, which is called as Snowflake and BigQuery in the between. So when we say what is a data warehouse, which is storing the data, right now in Cars24 ecosystem, we are supporting multi-data warehouse architecture. That means we have more than one data warehouse, which is enabling business solutions through different visualization tools and services. At the rightmost end, we have visualization tools like Tableau, Apache Superset, and then G Sheet is also consuming our data from Snowflake, majorly. Coming to some numbers about how much our ecosystem is handling as a day-to-day load. So there are 280 connectors which Fivetran is syncing the data into Snowflake, out of which there are 178 application databases. These application databases are MongoDB, SQL servers, MySQL, Postgres, right? And then on the Google Sheet side, so Google Sheet is because heavily used by the ground teams. There are 570 Google Sheets that we are ingesting into. Yeah, we are ingesting into data warehouse on a regular basis, day-to-day basis. There are 50 custom API pipelines that we have built, which is ingesting this data into our Snowflake data warehouse. On top of it, when we are producing this data, making it for use of business, these data are basically reported or visualized via Tableau and Superset. There are almost 600 active users of Tableau with 2,600 dashboards. Okay, within that dashboard, there are multiple views, reports that we call as. There are 19,000 views that are available in Tableau. On top of it, for the Google Sheets that are being heavily used by the ground team, there are almost 3,000 Google Sheets distincted by their Google Sheet ID and name range, which are getting populated on daily basis via Snowflake through our custom API pipeline. Okay. Now that we have seen the picture, this is more or less a deep dive into how the numbers are and why they are working around that. So for the ingestion pipeline, like we have gone through Fivetran, which is supporting 280 connectors, out of which 178 are application databases. Fivetran majorly gave us two ways to ingest this data. Either we can build a soft delete model where the data is deleted or purged from the source database. Still, Fivetran will preserve this data into the data warehouse so that anybody who is basically working on the business operation side, they can build the insight which is with the data that is no longer available in the application systems. On top of it, Fivetran also gives us the historical mode where we want to capture all the changes that are happening in our source system, whether it is a delete operation, a update operation to the same inserted record. Everything is captured with all the CDCs. That is the historical mode which Fivetran supports for us. Then for the custom pipelines, like we have 570 Google Sheets for integrations to bring the data into our Snowflake data warehouse, and 50 APIs that are maintained on the Python code as custom API pipeline. Most of our custom API scheduling are managed via Airflow. And so when we talk about the data pipeline, we have also seen some of the data are getting written into storage buckets like GCS, S3. In total, we have 225 buckets through which the data is being written into Snowflake via Snowpipe or Snowflake tasks. Now, when we talk about exporting this data outside our data warehouse, so this data export involves Tableau as one of the highly used visualization tool, which has more than 600 active users who have built over the period of time, who have built 2,600 dashboards, which has almost 19,000 reports on it. Along with Tableau, we have now started utilizing Apache Superset, which gives us flexibility of unlimited user without maintaining the license per license cost. It is also actively used by 220 users, and majorly it's been used by C2B and even for the Autopilot business now as well in the new business category. Autopilot is one of the achievement of ours where we have completed this project by a real-time data pipeline. We look into that real-time data pipeline as well, where the entire data of Autopilot business is getting ingested, transformed, and then it is made available to the visualization tool within 5 minutes. Okay, coming to the G-Sheet side for the export, there are 1,600 distinct G-Sheets, unique G-Sheets, but with their name ranges, different name ranges, it covers about 2,700 plus data extracts through which Snowflake is populating the data into different G-Sheets throughout the day. On the execution side, there are almost 15,000 executions for these G-Sheet extractions throughout the day due to different frequencies by which the G-Sheets are getting refreshed. On the data warehouse and analytics sides, there are almost 300 users in Snowflake who are running ad hoc queries to analyze some data and then making ETLs out of it. So with that, there are actively more than 16,000 queries, ad hoc queries that are run by the Snowflake users every day. Out of the 2,000 ETLs that we manage through our stored procedure tasks, Snowpipes in Snowflake, there are almost more than 1.25 lakh queries that are being executed in Snowflake every day. With the scheduled report on Tableaus and G-Sheets, the execution is again more than 20,000 queries per day. Coming to the multi-warehouse ecosystem, now that we have seen that Snowflake along with BigQuery was being used, but that was not all that was there in the data warehouse ecosystem. Although today Snowflake supports 80% of the data in our entire ecosystem as a central data warehouse, making it available for almost all the users, data users in Cast24. But parallelly, we have Google BigQuery and AWS Redshift adopted over the period of time for different use cases. Many of the use cases were native integration because we have both Google Cloud Platform and AWS Platform in our ecosystem. BigQuery basically gives the native integration to all the services that happens in Google Cloud Platform. So Spanner DB or any other services in Google Cloud Platform can write the data directly into either GCS bucket or Google BigQuery. So early adoptions were because early adoptions were involved to use BigQuery as one of the data warehouse to start using the data for business solutions. So there we have support of BigQuery as well, which is also serving as an alternative to cover the business solutions and then push that data into Snowflake at the later stage. The adoption of AWS Redshift was across the real-time product requirements, where the requirement was to showcase some of the heavily used monitoring dashboards, which needs real-time data populations and sharing for the visualization. So AWS Redshift, because has a native connection with all the AWS RDS databases, using the DMS solution of AWS, data are made available into AWS Redshift and again being used into Tableau or Superset for visualization at real time. But on top of it, we have brought in up our own open source data warehouse called as StarRocks that you see in the middle. This particular data warehouse is completely managed by CAS 2014. This warehouse has equal scaling capability. This data warehouse supports the real-time data pipeline which we are live with for our Autopilot business. So we'll cover about this real-time data pipeline as well in our future slides. Now coming to the current challenges that we had in our data platform. So the very first challenge is governance and compliance. Many of you have heard about all the hashing that we have done into Snowflake, all the governance discussions that we have been part of. That data that is coming or generated by CAS 24 ecosystem must be secured, sensitized, so that not everybody can have access to it. On a compliance perspective, all the data that are being made available through data warehouse or any platform solutions should always be governed with proper authentication and authorization mechanism. So in order to support such flagging and sensitivity, we are now building our ecosystem, revamping it to classify better data governance and make it more sensitized than before. In the second point, like we see no tracking of source data ownership, is that we have been an umbrella company for over a decade now. And since the data is growing massively, the older legacy systems are now lost with the data ownership. With that regards, there is not a complete visibility of how the data, what the data is, and who will be responsible in order to maintain that data in the data warehouse system. So we are also planning to overcome that particular condition where data visibility or data discovery can also be a part of our ecosystem, which we'll again cover in our coming slide. On the third point, lack of documentation about the data, it's more about understanding what the data is, how the data is getting generated, how the data is flown into our data warehouse, what the data is for. And these basic questions should have always been present in the data warehouse ecosystem. But unfortunately, since that was not the scenario, it's our task list for which we are already working on. On the cost-effective capability, many of you have heard about Snowflake not acting properly, queries slowing down, always running into queues. There are a lot of factors which is driving this. Not just that we have a loads of data that is getting processed in Snowflake and loads of pipelines that are working. Snowflake has their own reason to not support the real-time pipeline currently in our ecosystem right now, which we are planning to parallelize by our data classifications and data discoveries. When we talk about managed infrastructure, it was more or less about the ecosystem that we have built in-house. But that's not the only place we'll be limiting into. We have already explored parallel warehouses, more or less proprietary and self-managed. And we'll keep on switching between the infrastructure, which will make everyone a platform independent ecosystem. So a user who is at the end using the data will only be responsible to understand the system in which they are working currently. Behind the scene, how the data is getting populated over there will all be revamped by the data engineering team. Improve productivity again. So because there is data duplicacy, there is redundancy in the data, all the source architectures or job redundancies all these things which will impact analyst works day to day, that will be removed when we introduce our data discovery tool in our ecosystem. The availability of non-aggregated raw data. Okay, so over the period of time, Snowflake has become a dumping ground for all the data that is coming or generated in Cast24 ecosystem. The problem with using a raw layer data directly into business solution is that every business will customize the data for their solution only. That will make data inefficient, or in reusability purpose, that will make data very complex. So in order to overcome such scenarios, there are process which a data warehouse standard practices that we'll be following, which will eliminate the redundancy in the data and make data available so that everybody who is trying to use the data will know beforehand whether the data is already transformed and ready for their use, or they'll have to do it from the scratch. That will reduce the amount of time an analyst will spend in order to prepare that data. Definitely, it will increase their productivity to serve the data more faster to their business. Now, this is the tool which I was talking about, which is called as Open Metadata. This particular tool plugs in with all the technologies that we have in our Cast24 ecosystem, whether we talk about data warehouses like Snowflake, BigQuery, Redshift, StarRocks, or we talk about source systems like source databases, production databases like MySQL, Postgres, MongoDB, SQL Server, or we talk about our reporting layer where we have talked about Tableau, Superset. This tool will plug in with all these data tools, and it will help us discover the data. By discovery, I mean, if I want to see how the data lineage goes from one system to another, which particular table is responsible to populate which table in the next iteration, and which table is being responsible or used in my data visualization. This tool will help you draw the lineage of the data, life cycle of the data, and also helps in data cataloging. It will give the description about the data. You will be able to understand what this table or this column represents. You will be able to understand what is the sensitivity of this data and why this data is being masked or hashed because of our data best practices. This will also solve our compliance problem, where we'll, since the data will be identified at the beginning when the data is ingested into the data warehouse, we'll have all the sensitivity check at the beginning, and all the data that are basically sensitive or important for business will be hashed or encrypted in order to make them secure. Now, coming to the actual architecture of how the data flow in Cast24. So now that we have seen tools, technologies, we have talked about different scenarios where data is being built, then there's data that is being utilized. How is the whole architecture flow looks like? So at the very top on the left side, we have all types of data, either structured, semi-structured, application data that is coming via API. All these data are basically ingested into our data lake. Right now, we have kept data lake different, but if you understand it by Snowflake, data lake and data warehouse is all Snowflake for now, which we are going to break it down into two different systems, and everybody who is handling or using data from Snowflake will sit over here at the data warehouse level. So source system will make any changes, their data warehouse will never get impacted, and their business downtime will never happen. Right now, the major challenge which we face in Snowflake is that every business is using the raw data, which is heavily dependent on the tech infrastructure. Let's say tech changes their infrastructure. The whole structure of the table has changed. A column is added, a column is dropped, or a table is completely changed, or the database itself has gone. The business will stop right at that moment. But having a data warehouse in place will at least have a stale data to picturize. The new data with changes might not flow, but the data warehouse will still stand and serve the business till the last point what it has. Now, once we started ingesting our data into the data lake, the data lake will be responsible to serve prior needs like the ML workflows, the ML jobs, which are running inspection or pricing or refurb kind of activities, which are producing data through their ML services. They'll be able to do it right from the beginning at the data lake level. Whereas business who's heavily dependent upon the data that is available will sit across the side of data warehouse. At the same time, when we talk about how do we able to enable real-time analytics, so when we produce the data from the source system through our data ingestion pipelines, there'll be two flows. The data will flow either on batch or stream manner. The batch data will sit on the data lake for sure, but the stream data will directly being ingested and utilized by the downstream applications. The stream data can be utilized directly by ML services. The stream data can directly be utilized by visualization tools as well, making it available for a short span, but have high availability to monitor or report any of your data in your visualization tool on real-time basis. When we talk about batch data, the data lake will process these data in batch, preparing it for data warehouse. Now, when we talk about data warehouse, it's all about layering the data to making it concise, business relevant, and reusable. So in order to do that, we'll create two additional layers on top of the raw data that we have ingested. Let's call it silver and gold. The silver layer will have very niche fact dimension modeling, and fact dimensions will be able to help us determine which particular table will be able to solve which business use case and can be extended to solve many more business use cases as well. The reusability with that will extend. At the same time, they will also ensure that there is no duplicacy since the fact and dimension is already available to solve the business problem. The gold layer is more customized to a specific business, which will only copy the aggregated data at the layer where a business only wants to see a particular insight. That will only be shown on the gold layer. And both visualizations and data sharing further can be enabled through data warehouse again. So business will heavily depend on data warehouse, and we are trying to make data warehouse more robust and scalable so that there'll be less downtime, no downtime, I'll say. And at the same time, there'll be data layering, which will ensure that source changes will not impact the architecture of business data. Now, when we talk about what else we can provide with the data that is there with us in our data warehouse, we can make this data available for self-service. Any business analyst, a person from tech product or any other team wants to just see the data, what it is, how it is, and I just need a sample of it. They can always have a self-service. On top of it, we have been coming across through many problems that data is being shared with third-party vendors or partners. Now we'll also have an API service that will be able to do that on behalf of any person sitting and give a data solution right away through API solutions. So we are already building a pipeline of API solutions from our data warehouse, which will serve our partners with the data that they are sharing with us. Now, when we talked about multi-warehouse architecture, we have also talked about why we are exploring our alternatives of our data warehouse. So many a time, if we see what a data warehouse is, all the companies like Snowflake, BigQuery, Redshift will only talk about the first two components, that's compute and storage. They'll always say कि मैंने compute अलग कर दिया, storage अलग कर दिया, अब आपकी cost या तो compute पे scale करेगी या storage पे scale करेगी. That means even if I'm massively increasing the users who are just querying the data repeatedly, only the compute is affected, whereas storage will always be preserved. Or I'll say there is not much user in my system, but I need a storage layer which can have terabytes of data, hundreds and 120 terabyte of data is available. I just need a storage space which is cheaper. So data warehouses usually talk about this allocating these two components where compute and storage can work in their own function and their cost will not impact each other. I don't have to scale both of them together in the same plane. On top of it, there is two more things that makes any data warehouse their proprietary. That is their catalog and format. Snowflake says, I have database name, schema name, and table name. BigQuery says, I have a project where I have dataset ID and then table name. All these things are called cataloging, and these cataloging are proprietary to their business. That is the reason we were not able to expand or come outside of these infrastructures and remains monolithic with our data architecture. Now we have evolved out of it. We maintain our own catalog. We maintain our own data formats. Formats, at the end, every data warehouse is just another file management system. Just like HDFS, if you have heard of, all other warehouses have their own file systems, which manages data into small set of files. Now, when we have files, there can be one of the file formats that are available in the market, or they have created their own file format, like BigQuery has their own file format. Redshift has their own file structures. So because we know how to work with files, whether it is Parquet, Evro, JSON, etc., we can directly use our file formats for our data warehousing. At the same time, for the cataloging, if you guys have ever heard of Iceberg or Delta Lake tables, they are open source table formats, which basically gives us the capability of reading a file as a table. I can open up an Excel sheet and give a SQL query to it. My Iceberg table or Delta Lake table will give me the capability to do that. That is the catalog which we have introduced for our data warehouse alternative solution. Okay, I'll come back to this a little bit more time. So when we talk about compute, on compute side, we have basically did the POCs with several open source data warehouses like Apache Doris, StarRocks. There is ongoing POC around ClickHouse. But so far, we have implemented StarRocks as one of our custom data warehouse solution, which is supporting our autopilot business in streamlined manner in day-to-day work. For the storage, when we talk about storage, it's not about storing the data in any of the shared folder or bucket. Storage complexity is more about making data available at the time when we need it. So instead of talking about the storage in any bucket sense, let's think how data can be stored in a layer or a tier where I can say I'll have a hot tiering of the data, which will have small set of data, maybe a day or two older, which will always be real time. That data, if we talk about our normal laptops that we use it, is similar to the SSD drives that we use. So that always run faster, right? So making data available at the hot tier is equivalent to making data available at the SSD drives. So that drive will always fetch the data at the faster speed. The IO will always be faster. Tearing the data into a warm or cold layer, making it available for heavier analytic research, like I want to do a historical research, I want to train my ML model. For that, I need historical data, which might not need to be stored at a hot layer. I can use HDDs or even storage bucket for that tiering. So in order to enable that capability, we have used one of the open source tool called as MinIO, which gives us the storage flexibility to store our data at tiering. It gives us the flexibility to maintain data live for a particular amount of time, let's say 1 or 2 days, and then make it available at the backend in GCS bucket for our use case. Now coming to the real-time data pipeline that we have been talking about so far, that is already running for Autopilot business. So when we talk about real time, any data which is getting generated from the source, it needs to be available to be consumed at the same time. What makes it available? If I use tools like Fivetran or custom pipelines, they'll need a trigger. The trigger will make it a scheduled code, not a real time. So in order to make it real time, we use Kafka, Apache Kafka, or Google PubSub. So these are just message queues where data are pushed and forgotten. There are different ways to handle that data. What we focus majorly here is how the data is available at the real time. That is through messaging queues like Kafka and PubSub, which we are ingesting into our data lakehouse and then making it ready for our data warehousing by the two layers that we have talked about, silver and gold, and then making it available for usage of downstream applications like Apache and Tableau, Apache Superset and Tableau. Now, when we talk about the structure of our managed ecosystem, like we have already discussed, the storage, the storage is basically solved with Menio, which has storage policies that tiers the data in hot and cold layer. Then we have Google Cloud Storage, which is basically being utilized when the data is tiered after a several period of time as a cold layer to store the historical data at cheapest cost available. And then for the compute, because we are solving the compute engine can be StarRox, can be ClickHouse, can be Apache Doris. These are the tools that we have came across with and did the POC across for our data sets, but there are ongoing POCs that we are planning to do with other data warehouses as well. For the transformation of the data, when we say preparing the data from data lake to data warehouse, making data transformed into fact and dimensions, for that we have used a transformation tool called as DBT. DBT helps us to write those SQL codes in a programmatic manner that can be reused, programmatically being scaled into populating multiple data by one program or one query. And the downstream of currently the Autopilot project is using Apache Superset for their downstream for reporting and visualization purpose, but StarRox, ClickHouse, Apache Doris have native connections with Tableau as well, as on date. So with this, I have covered almost everything that is there in the flow of current architecture of our data warehouse. If Abhishek wants to add anything on this.
No, I think you have covered it all and above. The couple of things which I wanted to add is that, one of the things that we have missing in our data ecosystem is the ability to catalog it properly. After POCs with multiple paid and open source solutions, we have finalized one that is going to come, very soon, maybe in the next 3-4 weeks at max, which will solve your documentation, which will solve your cataloging, lineage, all problems accordingly. The second thing which I, have been working with different folks in the tech team, that they feel that, the real-time data availability is a challenge. We, as Anubhav mentioned, that the challenge was not to make the data real-time available. The challenge was how do we dissociate the different components of a data warehouse by separating them into, compute, storage, format, and, compute, storage, format, and the catalog, right? So that is something that is also, working very well in one of the POCs that we have done with Autopilot team. So that is the next thing that we are planning to scale. Right now, one of the primary use case of, having AWS Redshift is because of the native integration of, RDS servers with AWS Redshift, the data availability on Redshift is in real time. If we are able to solve that, we can go back to, lesser number of data warehouse, because frankly, there are not a lot of organizations where, all the big data warehouses are in use. we use BigQuery, we use Snowflake, we use AWS Redshift, and we use open source as well. Frankly, I have not seen anywhere where, this is being used, and this is not something that, is easier to maintain also. Planning to, move to a more leaner and more optimized architecture there as well. One thing that I would like to add here as well, that, because of the lineage, because one of the complexities that, so right now we are in the middle of the migration of Snowflake from the AWS Sydney data center to Mumbai data center, and one challenge we are facing is that we have around 25,000 tables in Snowflake. In any normal business, the count of tables within a business is less than 1,000. It's generally in 3 digits. We have 25,000. It's massive. It is basically nothing but a legacy accumulation of over 5-6 years since the time we have Snowflake in our organization. Now, the realization there was that, there are a lot of services that started as a monolithic architecture in the beginning. They have been deprecated and have been replaced by, faster and leaner and more optimized services on the tech side. However, because there is no downstream visibility of those, changes happening in the architecture, we are still maintaining them. And the worst part of that is that not only it takes up cost and it takes up bandwidth to manage those pipelines. There are analysts and there are jobs that the analysts have set up. They are using the tables which have been deprecated maybe years ago, and if they are using it, then that is another big problem that we being a data oriented organization cannot afford to continue using data sources which have been deprecated. I think these are a few things that, in the coming few weeks, and definitely in the coming few weeks, open metadata is going to solve. And in the coming couple of months itself, you will see, the scale up of the real-time pipelining use cases as well. So I'm pretty sure, this is one collaboration that I would, very happy to do with the, my counterparts in the tech team as well, because right now, the data warehouse is primarily a way in which the analytics team is using the different data objects, right? If we are able to stream it real time, it powers not only the ML, not only the DS, not only the analytics use cases, it also empowers the data sharing between different business verticals from a central way. And there is nothing more, while we are trying to move in the platform oriented architecture, this data platform is basically, the most central way you can get to be able to pull any data related to any business vertical. Wherever there is any special requirement with respect to compliances, we set it up at one place, it gets solved across the board. If there is any requirement of, data being, latency being higher or anything like that, we solve it at a single place and we are good to go. Rather than having, multiple places where we need to solve the same problem over and over and over again, the centralization and the platform, making everything more into a platform level architecture, solves so many problems. And not only increases the productivity of the analysts, but it also increases the productivity of the developers and the tech folks who are working to support this architecture. I think this is it from the data platform team side. If there are any questions, happy to answer them.
If there are no questions, then he has questions. What is data cataloging and lineaging? He has said these two words like multiple times. So who knows what is data lineaging and what is cataloging? So why you're not asking, guys?
So, okay. So data lineage is pretty straightforward. So let us suppose, all those folks who were here about 2-3 years ago and are still here, they would notice one thing that, initially our inspection ID was of 10 digits. And around April 2022, the ID was made to go from 10 digits to 11 digits. And it created a lot of chaos. It broke a lot of systems, broke a lot of reporting. And the worst part of that was that at that point of time, we had a outing in, Manesar in some guest house. So our, teammates, the people who were facing this problem, were, working on solving this, while the rest of the team were playing, some team building activity or treasure hunt चल रहा था, I think, if I'm not wrong, right? प्रॉब्लम क्या आया, क्योंकि हमको ये पता था कि देयर इज अ चेंज दैट इज हैपनिंग इन द इंस्पेक्शन आईडी, इट इज गोइंग फ्रॉम 10 डिजिट्स टू 11 डिजिट्स. वी डिड नॉट नो कि वो चेंज कितनी जगह पर इंपैक्ट करेगा. देयर वर फ्यू पीपल हु वर अवेयर कि हाँ ये दीज आर द 5 प्रोसेसेस वेयर इट विल इंपैक्ट. They were taken care of before the change was made live. However, there were 50 more processes that nobody has any idea of, that this is also using the same data of the inspection ID, and it is going to be used by multiple downstream systems. And if there is a change in the ID from 10 digits to 11 digits, it will break those systems. Now, what lineage does for you is that if you look at one table and you try to trace where that table is being used in the downstream systems also, and if you have created a derived table, you want to see that where that derived table is being used in the downstream systems, and from where the derived table is getting that data. That entire graph, that entire visualization is called lineage, which gives you an understanding of what change is going to impact all those places which are in our ecosystem. The more specialized feature of that is that instead of a table level, instead of a data object level, I'm able to get the lineage of a single data field within a table. A lot of paid tools also do not provide this functionality, which is something that the open metadata open source tool is providing us, right? This is what lineage is all about. Data cataloging has, two different definitions. One is, in this discussion, in this conversation also, we have used catalog in two different ways. One is the catalog in terms of data engineering, data architecture side, which is a proprietary of how the data is being stored. There is a database which keeps a mapping of where that data is, what is the file format, from where it has to pull all that information to be able to execute the queries the analysts are writing on that. That is one catalog. The second catalog is nothing but the description of that table. Right now, as I said, there are 25,000 plus tables in our ecosystem, and nobody in the entire organization can say that I can tell you which business unit this table belongs to, which owner, which product member is the owner of that particular data, which module in the tech ecosystem is the owner, is the place where this table is getting the data from. That kind of cataloging, that description about the table is the second kind of a catalog. The first cataloging is something that we are solving architecturally by getting open source tools integrated within our ecosystem. The second cataloging, which is the metadata about the table, is being sorted with the help of open metadata.
I hope that answers. Any other question? Then again, the question is, what is open file format and why we should use it? आप लोगों के लिए अभी question. बताओ, आप ही बता दो.
Okay, so when we talk about file formats, it's all about storing the data in different contexts. I want to store the data in a tabular format. I want to store the data in columnar format. You have been studying about it or going through about OLTP, OLAP systems. All these systems are different from each other because how they are storing the data at the back end of their systems. When we say Parquet, Avro, JSON, all these file formats are basically the structure of maintaining the data. So when we talk about data warehouses, they are primarily derived in making data available at columnar format, just like Parquet that we have. So it will be able, it will basically enable the readability of the data at a faster scale. When we talk about any data that is being fetched from data warehouse for any of the analytical processing, we always fetch it at the column level. That is why all the data warehouse always store the data in columnar fashion. All these file formats are just a replica of how data is being stored at the backend.
Any other question? So we talked about compute, storage, catalog format. So you guys tell me how the queries are getting changed and what are the various different ways that we can query this data warehouse. While we know that there are different formats, we know that we need a data at a very different scale. We may need a data of hundreds of GB at a time. So how this whole query ecosystem works?
Okay, I'll take an example of a very simple query. Let's say I'm hitting a query, select employee name from employees table, where department is something. Department is HR. So if I break the query into the components, we have heard about all the databases, since we are all very user friendly with the databases. In database, we have a concept of query engine, right? So the query engine major work is to translate that query into a computer understandable format so that the IO can perform. Now, when I talk about the whole architecture that we have in front of us, if this is my query, my compute is responsible to make it available for the rest of the three functions to give the data to the end user. The compute will take this query, will process this query. The storage will give the data. The select employee name from employee, where department is equal to HR. The employee table is being fetched from the storage layer. The catalog is responsible to find that employee table at the storage layer. The file format is responsible to get the actual data that is behind that employee table catalog from the storage layer. The compute is responsible to add all these aggregations, like I need to find only the employee name, or I need to filter the data by department is equal to HR. So this ecosystem basically supports or help us majorly. So I have been talking about columnar format. Since warehouse is all about columnar format, because analysis is all about understanding a particular impact on a business, not to so it. So I'll take another example how we basically use data warehouses. At a point of time, I'll try to use a slice of my data to understand the business impact or evolution of the business. Unlike any of the transactional system, analytical systems are more about understanding a slice of the data. That is why we have fact dimension modeling instead of transactional data replication. Facts and dimension will break down those columns into a business relevant tables, which will only have the relevant columns that will serve a particular business.
Great. Any other question, guys? Or before we wrap up? Cool. Thanks. Thanks, Anubhav, and thanks, Abhishek. And thanks everyone for attending. And hope you will now get excited about learning more about the data. And these two guys are the go-to guys. They sit on the fifth floor, but they revolve around here. So just please use them as much possible. They have not talked about distributed queries. They have not talked about the deeper concept. We'll make sure that we'll have another session. But in the meantime, whatever queries you have, whatever doubts you have, whatever the learning. So for example, the Medallion architecture I love them to have one full session on that architecture itself, though we just got introduced to here. So we'll have more sessions. But in that meantime, please keep your curiosity level high so that you can reach out to them more and learn more. Okay. Thanks, everyone. Happy
Thank you,
evening.
guys.
Thank you.